Hi class, let's take a look at problem 4a. Now notice that it's not in the proper form. This is because all the problems that we've been doing technically have the absolute value by itself. So let me just show you the formulas. And here's the basic idea. When you're solving absolute value equations or inequalities, they all have to be in this format. And the format that I'm referring to is the distance has to be by itself equaling a value. The distance technically by itself less than a value or greater than a value. And yes, you could have less than or equal or greater than or equal. And notice that the one that we have has constants or other possible values. So let me go back to it so we can see it. Okay, here we go. So in this situation, the inequality is not ready for us to actually do any work on it in terms of separating it. The first step is to technically get rid of this value and have the inequality by itself in terms of the absolute value portion in one side. So what I'm going to do here is I'm going to be dividing by -2 and divide by -2. And remember that this causes a switching of the inequality. At this point, we have x plus 5. The original statement was greater. Now it's going to be less than, and in this case, this will be 4. At this point, we've isolated the actual inequality, and then we can actually break it down and solve it. The only one is to solve in graph. So at this point, we're going to have to solve two inequalities. Actually, wait, because it's a less than, my bad, not two inequalities, just one. X plus the values of 5 less than 4 and greater than -4. So it is two inequalities, but one statement that we're rewriting as. And the reason I'm saying it is 2 is because you're reading it as x plus 5 is less than 4, and x plus 5 is greater than -4. Or your unknown is bounded between 4 and -4, which is what we have here. Now, in order to solve it, we'll simply subtract 5 from both sides. And we're going to end up with, on the left, -9 less than x and less than -1. And at this point, this is our solution. So let me just rewrite it here. So solution our x is bounded by -1 and greater than -9. Remember that all of these, you're going to have a min and a max. They want a graph. So the graph, and obviously not to scale, I'm just going to put 0 as a reference. This would be -1, and I'll just put -9 to the left. Our inequality starts with a greater, meaning no equality. So we end up with the boundaries not being included. And then technically every value in between. So we're talking about every value in between these two. And that happens to be our solution in the graph for part A. Let's actually move on to B. Once more, B is not on the proper format because you're basically subtracting from the absolute value a -2. So what I'm going to do here is simply add the 2. And this modifies the inequality as absolute value of x plus 5, it's greater than 10. And as we're solving this one, remember that, well, it's a greater one, so we're going to have to solve the following two statements. This would be x plus 5 less than -10, or x plus 5 greater than 10. And then we'll be subtracting 5, which is going to give us to the following statement. X is less than -15, union, I'll just write it as or, x is greater than 5. So our main solution, let me box these two and then rewrite it. Solution, x is less than negative 15 or x is greater than 5. The graph of this one, this will be 0. I'll just put 5 here and negative 15. And then also it's a greater statement originally. So as we do the breakup of those two, we're not including the boundaries. Also, we're talking about a distance. So we end up with x is greater than 5, all the values to the right, and x is less than negative 15, all the values to the left. And let me just box in our final answer. That's it for A and B. Let me just check again. Adding the 2 will give us a 10, less than negative 10, greater than 5. And that's it for B. Careful on C because it looks very similar to A, but observe the following. So on this particular one, as we try to rewrite it and we divide by negative 2 and negative 2, we're gonna end up with a absolute value of x plus 5. It's greater, and this is supposed to be a negative, than negative 4. So dividing by the negative 2 switches the symbol from less than to greater. 4 divided by negative 2 is negative 4. And at this point, we're technically done. And this is because of the following. When we're looking at inequalities, any unknown will always be greater than a negative value. So this inequality is equivalent to technically rewriting that as x plus 5 is greater than or equal to 0. Meaning any number is going to satisfy the statement because the minimum that this can be is 0. You cannot have a distance that is technically less than 0. It's always going to be greater than or equal to 0. So this particular one, it's one of those all real numbers. So let me just write it as the solution. All real numbers. The graph of it, since any value will satisfy the inequality, we would typically put 0 as a reference. And then from 0, every value, let me make it a little bit thicker, every value to the right, and technically every value to the left. So this particular one, because we end up with a statement that happens to be greater than a negative value, it's all real numbers. Not to be confused with the previous problem that we did earlier. The previous problem, we had an unknown less than a negative. That's a no solution. Remember that all of these are absolute value statements, so you're looking at distances. So for the last one that we just did, because we end up with a distance greater than a negative value, all real numbers. If it had been less than, no solution. The minimum that can be is 0. That's it for problem 4. We'll put the rest of them on another video.